speaker is Kathryn Whitaker, also known as Katie. I'm honored to present her. She graduated with a Bachelor of Science degree in Meteorology, cum laude, from the State University of New York at Oneonta in December of 2003. In May of 2002, Ms. Whitaker was chosen to receive the Robert W. Caputo Award for Academic Excellence in Meteorology and contributes to the Meteorology Department, contributions to the Meteorology Department. She interned as a meteorologist at WKTV in Utica, New York during the summer of 2002. In the summer of 2003, Ms. Whitaker interned as a meteorologist at WBNG-TV in Binghamton, New York. After graduating from the State University of New York at Oneonta, Ms. Whitaker spent 2 months as the lead replacement weather producer for WKTV in Utica. In December of 2004, Ms. Whitaker was hired as a junior meteorologist at a private weather forecasting company located in the Hudson Valley. While working at the forecasting company, she was responsible for developing written forecasts, giving phone consultations to clients, recording forecasts for weather phones and radio stations, activating the company's severe weather alert system, assisting with marine forecasting when necessary, and writing occasional weather analysis for civil court cases. Ms. Whitaker is a graduate of Pace University in Pleasantville, where she completed a Master's of Science in Teaching with a focus in adolescent Earth Science. Ms. Whitaker is currently an Earth Science, Meteorology, and Astronomy teacher in Red Hook High School, located in Red Hook, and is a New York State Master Teacher. This is her 13th year of teaching Earth Science, and she continues to write past weather reports and develop forecasts on a regular basis. Go right ahead, Katie.
Well, thank you so much, Alex. I think that about covers it.
Katie, before you start, I told you I would do this, and darn it, I did it.
Okay.
I forgot to mention the video things. We'll let Katie start in just a second, but one of the things we like to do to make questions obvious, I believe that she's willing to take questions at any time, but it's a little hard to tell if you got it unless you just speak up. So we like to ask everybody to turn their video feeds off. And then what we use as a way of really announcing the fact that you've got a question is, if you do have a question during the talk, turn your video feed back on. We'll spot you and get you on it. Okay, I'm sorry, Katie. I knew I'd do that.
You're fine. Thank you so much. Thank you so much for having me this evening. I would first like to thank MHAA for inviting me to speak with you this evening. It's certainly a pleasure to be here. So as Alex stated, I am currently a high school science teacher at Red Hook High School, which is across the river from Kingston. And currently I'm teaching astronomy as a half-year course, and that just began in the last couple of weeks. Previous to that, I taught a half-year course on meteorology. So it certainly combines a lot of aspects of earth science. And my goal today really is to talk a lot about, we're sky observers, right? Whether we're meteorologists or astronomers, we're looking at the sky, making observations. And so I really like to tie together the concepts. And so when I was thinking about the presentations, I was thinking about ways that I could tie both meteorology and astronomy together. So first thing I'm going to do is ask for just a couple of reactions. And what I'm doing throughout my presentation is trying to mix in some of the teaching strategies that I use as a teacher, whether I am remote, hybrid, a mix between the two, or completely in person. So what I'm going to do is just ask a couple of questions. This is called a dipsticking activity, and just give me a reaction if you can say yes to any of these things. And then we'll come back at the end and see where the understanding has taken place. So if you've used clouds for forecasting before, give me a reaction. Perfect. All right. If you have seen a sun or moon halo, give me a reaction. Yeah, thank you. Perfect. All right, very good. All right. If you know your moon phases, good. Okay. Excellent. If you know weather outages like red sky at night, sailor's delight, and what ideas they're based on, not just the outages, but where the science comes from. Okay, great. If you've used animal behaviors for forecasting, whether it's your own cat or dog or birds or things like that. Okay, great. And the last one, if you know the connection between sunspots and cloud cover. Okay. All right, great. Thank you so much for that. That's good because it gives me a little bit of an idea of backgrounds, and there's some that I got a lot of strong responses to. Seeing a lot of great things in the chat coming up as well. That's excellent. And from this side of the screen, it's very helpful for me to say, like, okay, there's some familiarity with using clouds. There's a lot of people responded to the sun or moon halos. Knowing the moon phase is great. So those are things I'll spend a little less time on, but then things like sunspots and climate, maybe I'll spend a little bit more time on. All right, so while we're still kind of doing this warm-up phase, you don't actually have to write this down, but as a classroom technique, this is something I call a stop and jot. Sounds almost like a store, but not quite. So just think about how you have in the past or presently use nature to like predict in your environment. And we're going to come back to that, and I'll ask people to share out if they feel comfortable with that at the end of the presentation, because as I go over things, there might be some things that stand out to you that you're like, oh, actually, I do use a lot more information from my surroundings than I'm aware of. But just think about how you use your environment to predict weather. Okay. So I'm covering a lot in a short amount of time, and I recognize that. I'm going to try not to go too fast, but I want to give a sampling of a little bits and pieces here and there. These are topics that my meteorology students, who are mostly 11th and 12th graders, find interesting. And so I'm just taking a little piece of each part to sort of bring a lot. I like to do that in general because if you're not interested in one topic, it's not what I'm spending the entire presentation on. And so maybe down the road in the presentation, there's something that will stand out to you that'll be more relevant and interesting to you. So my main topics for this evening will be forecasting using the clouds, which actually is how I got into meteorology to begin with. I really didn't know what I wanted to get my degree in. I originally went to school for geology, but my very first day of college was a meteorology class. And I still remember it like it was yesterday. The college professor came, he was late, came out, opened the classroom door, light shining around him, came out, he was an old man, World War II veteran, and 2 months of meteorology with him. And he just used the surroundings. We didn't use computers. We didn't use any technology. It was all observations. And that really sparked my interest in meteorology and had me change actually my entire path for college. I transferred schools and went into meteorology from there. So forecasting using the clouds, we'll start with that. Forecasting using the stars and moon, talking about like sort of like observations, like optical things that can give you a heads up on the weather to come. I know like with the conjunction in December and chasing the comet around in the summertime, I was paying close attention to the clouds because it gave me an indication during the day if it was worth having my stuff ready to head out and hit the road to see if I could see some things. Then I'll talk quickly about sunspots, clouds, and climate change. That's a heavy topic. There's a lot to it. I'm not going to get too far into it, but I'll give you some resources and some basic information. And then I'll end with what it's like teaching astronomy and other earth and space sciences before and after, during a pandemic. It certainly has been a change in teaching styles and the way students learn. And I'm happy to share any information or questions that you may have about that. I'll answer what I can. All right, so getting into the clouds first, and this is just my main goals. So my main goals would be, okay, how can we use our surroundings to help give us information about what's to come? And again, like I was saying, like I would check the clouds during the day before like an astronomical event to see like maybe if it gave me an indication if it was worth going. So we're gonna start with the main classes of clouds. And I'm gonna pick the ones that we have maybe the most in like the Northeast that would stand out and be easy to identify and could be used for basic forecasting. So our main cloud classes would be the cirrus clouds, which comes from the word meaning curl or fringe, as in like hair. And those are going to be generally your high, thin, wispy clouds, mostly made of ice crystals. Cumulus clouds, that word's going to come up a lot, and whether it's located low, middle, high, cumulus means basically lumpy. So it means heap or pile. Alto is your mid-level cloud, just like if you think about music, if you think about altos are your mid-levels. And then the stratus are more spread out over a large area. I remember with the conjunction, I saw stratus clouds that day and I knew it wasn't a good sign because they spread over a large area and you don't get too many breaks in those. So to talk a little bit about each level of clouds and how you can use them for forecasting, I'm just picking out the main ones. I will share a resource with you that gives a broader representation of all the cloud types, but of course we don't have time for that this evening. But with your cirrus clouds, when you have your basic cirrus clouds, and I'll show you pictures in a moment, those thin wispy clouds found across the sky in high levels may indicate fair weather, but if you see them increasing and thickening, it could mean an approaching warm front. When fronts move in, they come in different styles, and with a warm front, it's sort of a top-down frontal system, and I'll talk about that in a moment. The cirrocumulus cloud, that cumulus word is back in there again, right? So cumulus means like lumps or humps. So when you start to see more of like and it indicates convection, anytime you see those lumps or humps, they call it a macro sky in the case of the cirrocumulus. It indicates that you'll likely have precipitation within the next 12 to 24 hours. In tropical regions, it's not all that uncommon to see the cirrocumulus clouds ahead of hurricanes. And then cirrostratus clouds, I get really excited about those because they do indicate rain in the next 12 to 24 hours. However, cirrostratus are the kinds of clouds that you would see the halos with. And that's a really great optical illusion that people have been noticing a lot this winter. I've noticed on Facebook, a lot of people are posting pictures of the halos. So I'll spend a little bit of time on that today because it is certainly a really cool phenomenon that we've been seeing a lot of during the winter time. So these are just examples of those different cloud types. So again, these are your cirrocumulus on the left-hand side. You see the kind of lumpy, fluffy, I always think of like the mashed potato kind of clouds, show some convection, but in that level, you're not going to get precipitation out of these clouds directly. They could indicate that precipitation is coming, but they themselves will not produce precipitation. The cirrostratus clouds, 12 to 24 hours ahead of precipitation, and we can create the halos and sundogs and things like that, pillars. And then the cirrus clouds, high, thin, wispy clouds, on their own could be fair conditions, but if you start to see them increase and thicken, again, that could be an indication of a warm front. So I'm gonna take this away for a moment just to sort of hit that point home a little bit. And when I'm teaching, I like to mix up my style of teaching because not everyone learns in the same way. Some of my students really love note-taking, actually. I almost got rid of note-taking and they begged me for that time because they like to sit down and write. And they say they learn better when they physically write down the information instead of typing it. And I know me, myself, like when I'm reading something or proofreading something, having a physical copy in my hand makes it so I can understand it better. Some students learn better from manipulating things and moving things around. Some students learn better by seeing. So for the fronts, this is just a quick animation. This is a cold front. When a cold front comes through, it's going to bulldoze through. Cold air is more dense. It's going to push things out much more aggressively. With a warm front, it's a little bit a different situation because with a warm front, it's more of a ramp. So still works on the premise of density, right? Warm air always rises, cold air stays at the surface. Where the cold air and a cold front bulldozes through and forces things up more aggressively, so you get things like thunderstorms or much heavier downpours, the warm front causes the air to lift up and over more like a ramp. So ahead of a warm front is where you're going to see those high, thin, wispy cirrus clouds. And so when they start to increase and thicken, that's an indication that this warm front is pushing into your area. So if I'm standing at this location, right, my clouds have increased and thickened, indicating a warm front, which typically those will last for a much longer period of time than what you would see with a cold front. Altocumulus clouds, mostly water droplets at that point. Again, that word cumulus, lumpy, alto meaning mid-level. If you see those in the morning time and it's like humid conditions, those can sometimes grow. When I worked in the forecasting office for WKTV, where I did my internship, in the mornings, I was working there in the summertime. I paid very close attention to those cumulus clouds and something known as a cap, which basically keeps the air from rising. If that cap breaks because of high winds or a frontal sort of initiation, it expands up into these cumulus congestus clouds, and that can form later into thunderstorms. But the little puffy alto cumulus clouds, we call them sheep in a meadow, where the blue sky is the meadow and the puffiness is the sheep. Doesn't necessarily mean rain, but it's something to keep an eye on because it could mean that something would develop down the road. All right, and then my last set here are the stratus clouds. And the stratus clouds, not typically a great indication of the weather to come. So the cumulonimbus clouds are thunderstorm clouds. They are cumulus clouds, that congested clouds that grew and eventually turned into thunderstorms. It can indicate heavy rain, hail, thunderstorms, tornadoes, hurricanes, things like that. Stratus clouds, remember stratus means layered. So really that like gray, dreary, can last for a long period of time. If you have stratus clouds and you wanted to go out and observe, probably won't happen for a period of time. It takes a while for them to clear. Fog is a type of stratus cloud. Stratocumulus cloud, again, cumulus, lumpy, right? So more puffy. They'll indicate, they're not always precipitation clouds, but they can turn into the nimbostratus clouds, which are the last type of cloud here. And those are your dark gray, cloudy layer that completely blocks out the sun, often produce precipitation. And again, that can be long lasting. So cumulonimbus would be your thunderstorms, puffy, stratocumulus, the stratus on the left, and then the stratonimbus on the side. Okay, so to connect this to an activity that I did with my students, again, both my astronomy and meteorology classes are remote this year because to keep the school population lower each day, only half the students come in. And when the students that aren't fully remote, and for the students that are switching in and out, their electives are all remote. So I'm meeting with them on Zoom every day. So for the electives, we always meet on Zoom and everything I do is on Teams. So one of their activities was to take a picture of a cloud. And this is sort of like a cool activity to do anyway. Something that I've embraced about the pandemic is that students have devices. Our district has done a great job of making sure all students have devices, so they have access. They have access to the internet. And so I have them take a picture of a cloud. I'll show you the cloud ID here chart in a second. And at the same time that they take a picture of the cloud, I take them to a website called Mesonet, where they can get other information about the area. So temperature, dew point, wind direction, if it's currently precipitating. And then I have them track the weather for 24 hours and note any changes so that they can start to make those connections of when they see this cloud, it could mean this kind of weather. And if we think about it, when you think about early astronomy and early meteorology, early sciences were all based on people observing patterns, right? So even with astronomy, some of those early ideas were very incorrect, but thousands of years ago, people were making these pattern changes like every August I see Leo, right? And that's the time to plant. And they started to make these observational patterns that tied into more of the modern sciences that we have today. So this is the picture of the cloud chart, and you can click on them. It's a great resource, and it covers a lot more than what I've covered today. And then I didn't actually bring this up in advance, but this is a great resource. New York State Mesonet.org has stations all over New York State. So like I teach in Red Hook, they already issued a winter storm watch. I'm guessing that's for Thursday into Friday, because that could be a doozy. But it gives things like temperature, snow depth. If you go into it more, it gives you more information on what's going on. So if you're planning on traveling or going to look for something in a certain place that's not your own location, you can use the Mesonet to get the weather forecast and their local stations to that area. And they actually have cameras and things like that you can use as well. Okay, the last part of sort of the cloud section is about the best time to see like beautiful, colorful sunsets. Again, as a sky observer, something I typically see people looking for on Facebook and posting on social media are pictures of sunsets and sunrises, because it can certainly be a beautiful phenomenon to capture. To get the best, most colorful sunsets or sunrises, you're going to want good visibility so that the sun isn't blocked out. Low humidity is helpful too, as far as keeping it more clear. Partly cloudy skies, they say 30 to 60% cloud cover is the best, because you do need some light getting in, but you need something for the colors to reflect off of to create those beautiful sunsets and sunrises. Thin clouds are the best. So the cirrus clouds I talked about, the thin wispy ones. Cirrocumulus, also high level, but they're going to be more of the fluffy ones. And altocumulus, sheep in the meadow, spotty, broken up a little bit. Stratus clouds, you'll notice, are not mentioned at all, because those thin, like those layered clouds, darker clouds are going to block out the sunlight. So it's not going to do a lot for color. You tend to have more of a fiery sky at sunset because the sun is at the lowest angle and the farthest point from the earth. So it's traveling through more of the atmosphere. So more of those blues are going to get scattered. So what gets to us would be more of the red light. Okay, so that's my little thing on clouds. Moving along into sundogs, halos, and sunspots. So there are things that we can do to make connections with weather and climate with that. So one of my favorite phenomenon for meteorology are sundogs. Actually, sadly, the professor that I mentioned before passed away during the semester of meteorology, like mid-semester. And the day he passed away was the first time I ever witnessed a sundog. So it's always had a really big significance to me. But it's just an interesting phenomenon in general. A lot of people see it, and like I have a lot of friends that actually still ask me about them because they just don't notice them, or they're more clear sometimes rather than others. It almost looks like a second or third sun there. But it's an optical phenomenon. It's caused by sunlight refracting through the ice crystals in cirrus clouds. Patches of light and color are found at 22-degree angles to the left and right in the sun. So it's always at the same angular thing. You won't always see it so symmetrical. Sometimes you'll only have like a partial sundog. They're associated with the cirrus stratus clouds. And remember, the cirrus stratus clouds can indicate rain within 24 hours or so. So this just has a diagram of an observer looking at the sun. So at a 22-degree angle to the left and right of the sun is where you would see the sundog. If it's completely filled in, that's how you get your halo. So I'm going to skip the video now just for the sake of time. But I did link a video in there. So complete halo includes the sundog, but we'll go all the way around. Again, it can indicate precipitation within the next 24 hours. With the moon, very similar to a sun halo. Again, it's all about refraction through the hexagonal ice crystals, and it'll be at the same 22-degree angle. The moonlight isn't as bright as the sun, so you're not going to get the same colors that you would get in a sun halo. And sometimes it might be more of a haze, which would indicate precipitation within the next 12 hours. So moon halo, a lot of people were noticing these with a December snowstorm. I saw a lot of people posting pictures, and I was like, that's not a good sign, because it means that the precipitation was coming in, although it was a great sign because I like snow. But as far as wintry weather moving in, very distinct moon halos this year. The haze around the moon, that was something that the professor had taught us that semester in meteorology, that when we saw the haze precipitation with 12 to 24 hours, I think about it every time I see it, and it's been true every single time. And then this just shows a complete sun halo there. So sticking with the moon a little bit and going back a little bit more to my teaching methods. So I actually was going to bring that model to the presentation this evening, but we had an ice day today, and our ice days are remote. So I wasn't actually in the building to be able to bring the model back, but that's my setup there. You can see I have two computers going a lot of times. So I'll have the students on one computer, my roster and other information on another computer. And that's a model of the sun, earth, moon system. So explaining the moon phases and the idea that really, you know, you can only use the moon for forecasting, well, if it's clear sky, because if you can't see the moon, it's not really helpful. So certain weather conditions, but also only certain parts of the lunar cycle would actually be useful. So one of the other things that I use for teaching, one of the biggest challenges I would say of being remote and, you know, pivoting, there's been mornings where, you know, I'll wake up and be on my way to school and I'll get a message that the school is going to be remote for the day, is having those hands-on experiences. So instead of being able to give the students that model to play with and manipulate and spend time with, one way that we're sort of accommodating for that is by using some programs. This is one that we use in our school called Gizmos. And so this is one that I used with the students when I covered this topic earlier in the year. And so the sun is on the right, we have the moon, we have the earth. And so when I put this into motion, it'll go through the moon phases, and I'll ask them questions like, what part of the lunar cycle would nighttime observations of the moon helpful for forecasting work the best? Well, if you're facing the sun and the moon at the same time, like during your new moon and your waxing crescent in your first quarter, not going to be as helpful as when we go on the darker side from like the first quarter waxing gibbous full back around to the third quarter. So making those connections and letting them being able to see, first of all, that flag is pointing towards the Earth the entire time. So the Earth rotates and revolves at the same speed, right? So we always see the same side of the moon. So it's a way for them to sort of see that concept. Day and night, I review that with them as well, that our rotation causes day and night, and then the varying amounts of the lit half of the moon, depending on where we are in our cycle. So Gizmos is a new tool for me. I've never used it before. It's been a helpful program for teaching astronomy and meteorology. I used it today because we sort of switched to remote last minute. I had a feeling with the ice that we would, but it was sort of a last minute thing. So I did a Gizmos with the students today on seasons, and it was a great way for them to interact with the material and not just have me speaking at them or showing them a video or something like that. Okay, so moving into some adages. These are some other things that you can use, just sort of observations or things about your environment that might be helpful in making predictions about the sky and what the sky will be like with a short period of time. So weather adages are actually one of the ways that I start out the meteorology course, and I'm not going to spend a lot of time on going over all of them, or actually I'm only going to really spend time on the one. But the Farmer's Almanac, of course, has a really great overview of a lot of different ones. And what I have the students do is I have them choose a weather adage and then try to explain what they think is happening, and then actually research it and look into the science of it, and then see if it actually works. So, okay, red sky at night, why do you think it's red sky at night, sailor's delight? Have them come up with a hypothesis, observe it over a period of time, do some research, does it hold true or not, and then adjust their hypothesis. If not, I actually found that most of my students were able to make observations that supported the adages and they rang pretty true. So the way that this works, the way sunrise, red sky at night, sailors delight, red sky in morning, sailors take warning works, goes under the idea that during sunrise and sunset, the sun is low in the sky and it transmits energy through the thickest part of the atmosphere. So a red sky suggests that the atmosphere has a lot of dust and moisture particles in it. So we see the red wavelengths because those are breaking through the atmosphere. The shorter ones are being scattered and broken up on the way. So when we see red sky at night, that means the sun is setting in the west and it's sending its light through a high concentration of dust particles. And that means that high pressure stable air is coming in. So if the weather is going from west to east and the sky to the west is red dust particles, stable air, that's what's coming in for the next day. Red sky at morning though, so at sunrise means that now the high pressure is off to our east. And so it usually goes like that, right? High pressure moves in, high pressure moves out, then low pressure moves in, low pressure moves out. It's one after another. So if the high pressure is already passed, then low pressure will be moving in from the east. So that's a little bit of an explanation on that adage. Again, there's a lot of other ones that if you're interested in that is an interesting thing to sort of look up. For watching animals and animal behavior, I know from a very young age, I would just sort of notice, like if I was outside playing and I could hear thunder in the distance, but the birds were still singing, I didn't get too concerned. But as soon as they got quiet, it was time to go home. And that's one that's still really good to go by. Also, because I grew up in central New York, a very rural area, if I saw cows laying down in the fields, it was also time to get home because usually that would mean severe weather was moving in. Other things you can look for would be things like birds and bees. They think that the animals are able to sense the change in the barometric pressure and go to the nests or hives ahead of storms, which makes sense, especially for bees. If you think about like a heavy rainstorm could really devastate a bee. If it's flying, it wouldn't be able to fly through the rain. So it's able to sense the barometric change, and birds will also fly lower and lower air pressure. Humans, we have aches and pains sometimes. I know myself, I get migraines when the pressure drops, and they think it is due to the atmospheric pressure change as well as how it's causing pressure to expand or contract within your sinuses, and that can result in some pain. So people that have like broken bones and things like that, the pressure will impact how your body system reacts to those pressure changes. One of the ones I really like with weather is the cricket chirp and temperature. So to do that, it's pretty simple. You just count the number of chirps. Of course, we're far away from the cricket chirps right now, but in the summertime, you count the number of chirps you hear in 15 seconds, add 37 to that, and that will be the temperature in Fahrenheit. It says it's accurate within 1 degree, actually. And it's based on the idea, a physicist actually spent a lot of time observing these crickets and making these connections. And the reason why it happens is the higher temperature means a higher metabolic rate for the crickets, and that causes them to chirp more. So it's a more frequent chirp because of the warmer weather, and it relates back to metabolism. So sort of a cool way to make a connection there with the sound of the crickets and the frequency of their chirps directly related to the temperature. And I always notice in the fall time, especially, you can really hear those cricket chirps slowing down as it gets colder. Another indication that you can use is watching smoke. So whether it's from like a chimney or a smokestack, if the smoke is rising in the atmosphere, that indicates low pressure, right? Low pressure means lousy weather, right? So that means the air is going to be going up, and it'll create clouds and possibly precipitation. So if, like in this case, the picture is actually showing the smoke staying at level or sinking, that indicates high pressure, because high pressure, happy weather, the air is sinking down or it's getting pushed down, so it's not going to have the tendency to rise. So that's just a quick sort of thing that you can pay attention to if that's something in your area. So the last bit of sort of like content stuff that I have is about the sunspots. This was something I found really fascinating in my meteorology class when I was in college. And it stuck with me all these years. And I like to revisit it when I teach the course. So sunspots are darker, cooler spots on the surface of the sun, the photosphere. The photosphere itself has a temperature of just about 10,000 degrees Fahrenheit, and sunspots are cooler at 6,380 degrees Fahrenheit. They look dark only in comparison to the brighter, hotter regions. So sunspot activity goes on an 11-year cycle. And so it's going to decrease the cosmic ray flux by periodically increasing the solar wind. And the solar wind's greater magnetic field is going to deflect some of the cosmic rays that would otherwise hit Earth from elsewhere in the galaxy. So to make like a big overarching connection, increased sunspot activity means higher solar activity, which means stronger magnetic field, which means lower galactic cosmic rays reaching Earth, which means reduced cloud cover. Some scientists believe that the cosmic rays actually, what they call, seed the clouds and would cause clouds to develop more. So without the CERs hitting Earth, you're going to have less cloud cover, and that would technically mean some warming. Other factors to consider: in general, those high, like cirrus clouds, are going to contribute to the warming of the atmosphere. They let the sunlight in, but not going to let the infrared out so much. Low-level clouds is going to be more cooling, because you're just not going to have the sunlight hitting the surface. So it's going to keep it cooler. And of course, latitude, seasons, and underlying surface, meaning like snow and ice or ocean or grass area, would make a difference in the temperature as well. So one of the sites that I like to use, spaceweather.com, talks about that we are currently in a solar minimum. So we should have plenty of seeding for cloud cover if we're doing the GCRs. So far this year, the sun has been blank without sunspots 62% of the time. Of course, we're only a month and a half into the year. But the last 12 days in a row, there have been no sunspots on the sun. So I like this source a lot, because a lot of times I'll just assign the students to just like an activity to like sort of explore around the page and see what they can find. But it does track the sunspot activity. Okay, so I'm gonna go back to my starting ideas and look for some reactions. So if you have a better understanding of how to use clouds for forecasting, give me a reaction. Thanks, Jack. Thank you. Great. Thanks. Thank you. If you understand how to identify and use sun or moon halos for forecasting, give me a reaction, please. Awesome. Thank you very much. Seeing some stuff popping up in the chat too. Love it. Thank you. If you understand the moon phases, even if you did before, get them even more. Okay, great. If you know where weather adages come from, like red sky at night. Awesome. Thanks. If you understand better how to use animal behavior, some other things that maybe you can pay attention to. And if you understand the basic connections between sunspots and cloud cover. Awesome. Thank you. Any other ones that people use that like about their surroundings? I only covered, of course, a handful, but other things that you use in your environment to help you with forecasting or telling you about conditions? Okay.
I had a question for you, Katie.
Yeah, what's up?
So when I went and saw the, oops, I don't know, my cam's not there.
Okay.
When I went and saw the eclipse, the full solar eclipse, I noticed that there seemed to be almost a hole punched in the clouds during the actual eclipse time frame. Do you know, is there anything related to, I know the temperature drops with the shadow. I don't know if there's anything people have said, related to why there might, how that might affect the clouds that you're trying to view through. And then right after that, it got very cloudy. Now that may have just been that day, but.
Oh, that's interesting. I haven't heard anything about it, but when you brought it up, the first thing that came to mind was that drop in temperature. If it's a convective cloud kind of day, that drop in temperature could certainly decrease the cloud cover.
Gotcha.
Yeah, that'd be my first guess on that. Yeah, great question. Any other questions?
Yeah, there were two things about animal predictions. You mean tell me it's true that when cows lay down, it's going to rain?
Yeah. So they think that like when they like sort of like huddle up, like almost for like a protection thing. And certainly like with like severe storms, they know not to be the tallest thing in a field, I think.
Because we thought it was an old wives' tale.
Yeah. Yeah, the times I've seen it, it's yep. They do see a correlation there, yes.
I grew up in a city, and we go out to visit my relatives in the country, and we thought that they were telling us that because we were city people and we didn't know any better.
Yeah, I can totally understand why you would think that.
The other thing is, my wife points out when the birds, when weather's going to be bad, birds kind of land on a wire, right? And they all line up. Have you never noticed that? Yes,
I have. Yes. Yeah. Right. Yeah, they tend to stay lower. They tend to stay in the trees, like closer to cover. Right. Yes, they tend to sort of like hunker down almost and find a more stable spot.
If they're taking cover, I mean, they're out on like power lines.
Right.
They're all lined up, like.
Right. They just tend to not fly as much with the bad weather coming in. Yeah. Yes. So you won't see them flying around as much. Yep. That is interesting. And I always wonder too if maybe the wires are a little warm for their feet. It could be like a heated feet. Maybe it's comforting.
Sure. Okay. Thank you.
Yeah. Yep. You're welcome. Thank you. And I see in the chat, like doves in particular. Yeah, definitely have a response to that.
I have a comment. It's been a fairly harsh winter so far, and we just got a lot of snow and storm, but January was very quiet outside, and especially after that deep snow, the first snow of the season, it was very, very quiet. But I'm hearing birds already.
I know. I actually have noticed songbirds as well.
Yeah. I mean, they know it's spring, but we don't know. We're just seeing more of this cold weather.
I was actually just saying, I was like, they know something I don't know, because I think we're going to get another 4 to 8 inches on Thursday into Friday. Yeah. But I always have to remember, and I do a weather segment for school, and I do like a question of the week or like a fun fact or whatever. And one of the things I always have to remind myself even is that like the birds go based on the food. Like they don't get cold. Like I always worry about like, oh, aren't they going to be cold? It's freezing outside. They have a much higher body temperature than we do. So they're able to hold up against the cold better. So it's not a temperature thing for them. It's a food thing. Yeah. So they go based on the food. So if they follow the food.
And I'm thinking it's probably the length of day also.
Right, the daylight hours, right. Yep, I agree. Yeah, someone in the chat said never trusted a groundhog. I agree with that too.
I saw Joyce asked a question in the chat also. She was wondering if the sunspots that cause northern lights, if the sunspots cause northern lights, does that mean likely less clouds when that occurs?
So the sunspots are going to go along with the higher solar activity. So that would also correspond with the fewer clouds, yes. Oh wait, no, sorry. Sunspots, higher activity. Yes, right. So, right. Yep. Those things would all kind of connect in a way.
Higher activity, ionizing the upper atmosphere.
Right.
Yeah.
That's right. Right. Great. Any other questions? That's great. So I think the only other thing that I had on here was just about, Tim, did you have a question? I'm sorry.
Yes, I did. Two questions, actually. One, during higher sunspot activity, the temperatures are going to be higher here on the Earth?
Yes, but it's only, so they said like it only is going to impact the temperature by, like tenths of a degree.
Okay.
So on a long, like on a bigger scale, like they said like the, the little ice ages was correlated with the sunspot activity, but as far as like being able to dismiss, like we have a much bigger impact on the climate change than the sunspot cycle.
And the second question is the connection between planetary positions and sunspot numbers and the sunspot cycle.
I'm not really sure on that one, actually.
What intrigued me about that was years ago, there was a book written in 1983 called The Jupiter Effect.
Okay.
Which predicted that because of the syzygy, which was going to take place about that time, the alignment of the planets, there would be greater solar activity, and that would cause more friction on the Earth because there'd be more energy in the atmosphere, and that would shake the that would activate the San Andreas Fault. So that was the premise of the book. But there was a there was a really key graph in there, which showed the general planetary alignment and the sunspot cycle, and they matched up very nicely.
Oh, that's very interesting. That's not something I've looked into. I'm gonna make a note of that to check that, because that sounds.
Okay, I'm glad I had an impact.
Yes, thank you so much. I always, that's another teaching tool. I always have Post-its here just so I can jot things down like that. So thank you.
Oh, very good.
Anything else for me?
Question?
Yeah, I'm pretty much all set. I just, again, like just to sort of emphasize sort of what I do with teaching STEAM being science, technology, engineering, art, and math. In general, a lot of it, like doing the hooks, like having students like connect with the material is big. Dipsticking, like give me a reaction if is something I use a lot. My students also, most of them don't have their cameras on when we're meeting remotely. It's something that I encourage, but I don't want to put pressure on them for. So by doing that sort of like give me a reaction if is a way for me to know that they're also there and interacting. A lot of what I'm doing now too is like looking into doing virtual field trips and experiences like that. So they're still able to connect with the content. But the students tell me all the time that they miss paper. Like they're like, can you please give me paper for something? Because it's just a whole different sort of experience to be on a screen all the time. And I think we can relate to that. So a lot of the teaching that I do for my Earth Science, Astronomy, and Meteorology classes is very similar to what I do before the pandemic, where most of my work is a flipped classroom. So background information is homework, and then we apply the information in class. But looking for ways for students to connect, and it's been nice in some ways because, like I said, like I have them do a lot of observations from home and take the time to use what they have around them to make observations without really needing extra materials. And it's been a nice way to connect the material to them with our local surroundings. So happy to answer any teaching questions too, but otherwise that's all I have.
Marvelous. Well, thank you so much. Everyone's free to turn their video back on now if you wish.
Okay, I have another related question if Katie is still on there.
Yes, I'm on. Yep.
Okay. One of the most practical relationship between weather and our astronomy group is whether or not to call off a star party. We have a star party one weekend a month, preferably on a Friday night. And if that's cloudy, then we postpone it to Saturday night. Mm-hmm. But we have to make a call on that. And we have people, now we have dozens, close to 100 people from all over the place who travel to Lake Taconic mm-hmm. for our dark sky site. And so we have to make a call. And we go to various websites. Jack knows them the best, and Eric.
I want to point out I've had 100% record for the last 2 star parties.
Ooh, wow. That's great.
I'm keeping a chart. I make a guess a week ahead, the Friday ahead. And then the theory is that if I say there's not going to be a star party, then the universe has to interfere with me and make me wrong. Okay. So weather will clear up and it will be fine. And I can say, haha, see, you said it wasn't going to be there and we had one. Unfortunately, the last 2 months, I've been right a week away.
Oh, no. Yeah.
So Jack, could you tell her what
I do?
Sites you consult on? I go to Weather Channel and the Clear Dark Skies.
Yep.
But Jack has much more knowledge than I do about these things. So
yeah, the problem with Clear Dark Sky is that they only give you 3 days. So what I usually do is I use Weather Underground, which is predominantly, local site data feeds. And they also have a nice little graphic chart that gives you a picture of what they expect cloud level to be.
Okay.
And if I'm looking at cloud level and precipitation level that's high a few days ahead of time, and it flows into, the Friday, I'm usually pretty confident that it's not going to be a good day for us. On the other hand, if I've got cloud level that's low or non-existent and then coming in gradually towards the weekend, I got a better chance that we're probably going to have something good. It kind of depends on when it happens. It's these days when it's like, Monday is 100% cloud, Tuesday is no clouds, Wednesday is 20% clouds, Thursday is 80% clouds with a prognosticated sort of maybe fall off a little bit. And drives me nuts because I have to wait till, Friday to make a call.
Right. Because if it shifts a little bit, yeah.
Right. And then a few days out, I start using the Clear Dark Sky, and they use several Canadian and European models for what the clouds are going to do. And then I also use Astrospheric, which is a really interesting, primarily astronomy focused application, which combines all of this stuff and gives you a lot of data. And if you haven't seen it, tell you what I'll do. I'll poke it up here real quick and share the screen on it, and you can see what we see. Let's get, where's my screen share? Let's share. Got to figure out which one of these desktops it is.
Okay, well, while he's fiddling with that, is there a possibility we could have your contact info?
So yeah.
Sure. Maybe we could make a much better guess at what's happening.
So yeah, absolutely. I'm happy to do some forecasting.
Here's Astrospheric. Here's Astrospheric, and it has a top. It has a map which we can actually put in motion if we want. I don't know how the network will do for me here, but in fact, it looks like it's not going to do very well right now. I'll give it later on. but it tracks each one of these little things. I can move my time to a particular time, and I can see the location that I've set and whether there's going to be clouds there. And to get ridiculous, let's move to Thursday at 2 a.m. Blot, there we are. We can see we're pretty well covered in. But Wednesday at midnight, we've got a nice little hole there. We've also got down here some different seeing characteristics. We've got sunrise and sunset, wind, humidity, and oh, I'm losing my mind. What is dew point? That's it. That's what I'm looking for.
Oh yeah, that's good.
Then we also, then we have an extended cloud cover. So I use this as well. Like if we were going to have a party this Friday, I could slide down here and say, oh boy, that doesn't look very good. It's got maybe some minor clearing happening right here, but it's probably not going to be really clear until Sunday. So I can get a good idea from that. And then there's some other little information here, but Astrospheric is a lovely thing to use.
All subject to change up until the last hour, it seems. Forecast models they're getting better, but they're still not super.
Yeah, I agree.
Eric had a question in the chat too. He was wondering. I don't know. Can you see the chat? Yeah.
Yep.
So he was just curious if you had anything that you'll want to keep after COVID's done from the different style of teaching you've had to convert to.
Yes. I was just responding to that. So I would say like one of the things I found actually, like a lot of my students, I'm close with a couple of my students, and I asked them like, what is it like in the classroom for you? And they're like, honestly, they feel like they're learning a lot more this year than they normally do because the teachers are cutting out a lot of the excess material, and we're teaching what's called the power standards of just sort of like, what do we want you to walk away with? And so the kids are actually getting a lot more out of that. So I like, highlighting those sort of key concepts. I've also found that there's some students that are feeling more comfortable actually communicating through Teams and through Zoom. I've been having student meetings with students, and they'll feel more comfortable communicating with me on a computer like this than coming to me in person. So even though it's harder to connect with students in a lot of ways remotely, there are some students that are really like thriving in it, and like especially students that have anxiety about being in a classroom or being with peers, they're actually doing very well in the remote environment. I also like a lot of the simulations and virtual field trips as like extended opportunities for students that I would likely keep in. I do miss the hands-on labs, so I would like to do a blend of both, but able to provide both kinds of experiences for the students.
Okay, along the lines of being an earth science teacher, I know you teach in Red Hook,
yes,
which is very close, relatively speaking, to Lake Taconic.
Yep.
I have an hour and 20-minute drive to get there, for example. But so you're certainly welcome to join us at one of our star parties and maybe get your students involved. That would help you if you don't have a background in telescope use and real-time sky observing. I would recommend that you move in that direction.
That would be great. Definitely. I would love to connect. And again, a lot of my students are upperclassmen, so a lot of them could probably get there on their own, and that's not too far from Red Hook. So definitely an opportunity I'd like for them to have. So that's great. Thank you.
Yeah, I'll also mention something in that line as well. We have another individual who's not a member yet, I don't believe, but he's presented to the club, and he's involved a lot with radio astronomy, but he's also involved with a weather group that's primarily on Greylock, I believe. And they are actually planning to also come out to the star parties and do a little bit of, weather work out there as well. And that might be interesting.
Oh yeah, definitely. That's awesome. Very good. I just put up my contact information. That's my email through my district. And then I have a YouTube channel where I do a weather forecast every week. Sometimes I'll do a weather chat where I'll highlight some sort of information about like earth science, weather, seasons, some astronomy as well. So yeah, certainly feel free to use my email to contact me anytime.
Cool. I got one image I want to show you before you disappear because you were talking about sundogs. And when you drop your share there, okay, I'll reshare my screen.
Yep, I took mine out.
This is a lousy picture. I apologize for the quality, but this was taken on the walkway over the Hudson after one of our astronomy events out there.
Oh yeah.
And you can barely tell it, but there's two moon dogs.
Yep.
That's a full moon rise has risen, and you got moon dogs left and right.
Awesome.
And the moon dogs
would
be like rainbows, right? Or they're, oops, sorry. Sorry, Jack.
Well, they're kind of that way. It's a nice reflection, same as the sundog is.
Yeah, put that in our slideshow.
Yeah, well, that's a loud picture. It was funny because I as the moon rose, I noticed the circle, the arc around it, and I was like, oh, there's the arc. Look at that, and it just kept rising and rising, and then all of a sudden I noticed that there's two nice big bright moon dogs out to both sides.
Awesome.
I'm like, oh, so good.
That's great. And not all that common to see those.
Is there such a thing as a planet dog?
I have something a little bit off topic.
There might be, but you'd need an instrument to detect it, I think.
There you go, Greg.
I have something a little bit off topic, but not too far off. A couple of weeks ago, I was talking to a middle school teacher, and she teaches social science, I guess. Well, the topic was how much misinformation do these kids get? Because one of the things that she did a survey of the class, and she said 75% of the kids do not believe that we went to the moon. They think it had to be faked because we didn't have the technology to do it back in the 60s. Have you experienced anything like that?
Yes. There is a lot of misinformation, and it's difficult because it's really kind of like entrenched. Like I'm trying to think of like, I have a couple of flat earthers. I do.
Oh, me, I am.
Yeah. Okay. But there's a lot of like deep-seated misconceptions, like working with seasons. I have to tell them almost daily, like it has nothing to do with distance from the sun, it's angle, so there's a lot of those sort of misconceptions. And I think some of it, it's hard to get that. Part of what we're trying to do in the school is to teach them how to use resources and make sure that they're credible before they're using them. But it's an uphill battle with that. It's tough.
I assume you're aware that we're closer to the sun in January than we are in July. Yes.
Yes.
But that is an interesting point, though, that they think that we didn't have the technology, and it makes you wonder what would have happened had we had the political will back then to continue. Where would we be now?
Right.
There's a paper by a cinematographer who shows that back at the time of the moon landing, we did not have the technology to cinematographically recreate the moon landing. We did not have cameras that were fast enough to make that slow motion and stuff.
Right.
That was the technology we didn't have.
Yep. I do show Mythbusters. The Mythbusters has an episode on the moon landing. And I do show that in my classes under, like, I'm not this year, but under normal circumstances, I do, because I go through all these proofs of like the photography and the shadows and the laser on the moon, that kind of stuff, and the laser beam. So the reflectors. So it is something I spend time on because a lot, and I'm almost scared to ask how many of them believe that stuff. So
kids need to learn critical thinking.
Yes.
Yes.
Absolutely.
Very, very cool. Anything else? All right, that was marvelous. Thank you so much, Katie.
Yeah, thank you, Katie. That was really a great presentation. Really appreciate it.
Virtual round of applause, right?
Thank you. No, it's a pleasure to be here. So thank you so much for having me.
Good.
Wonderful. Well, feel free to stick around if you want.